Hi everybody. Today we're going to talk about chapter 21 and we're going to talk about confidence intervals. And I am using my fingers instead of my stylus because my stylus seems to be missing. Alright, so let's talk about the concept of confidence intervals, and let me give you an example before we get into the nuts and bolts. What if I say, alright, today is May the 4th, May the 4th be with you, and let's pretend I sell hot dogs. And I say, alright, for the month of May, I predict I'm going to sell 200 hot dogs. Oops. And for some reason, I turned blue. No, sorry, I'm going to sell 200 hot dogs. Not $200, but 200 hot dogs. Okay? So the month of May passes, and it turns out that I sold 202 hot dogs. Was I right? No, I was not right. 202. Oh, I've gone back to black again. Okay. I was wrong. When I make a guess like that is just one value, that's called a point estimate. And point estimates, though often simple to make, are not good in terms of, in the sense of either you're right or you're not. Okay? So, if you happen to hit it right on the nose, you look brilliant and happy and everything. Alright, so I guess 200. In reality, it was 202. What would be a better way of making my forecast? Okay? Well, what if back today I would have said, I believe that my values will run between 196 and 204. And then at the end of May, they came out to be 202. Now, would I say, am I right or am I wrong? And you would say, why, you are right, because your interval contains the 202. Excuse me. And that's the ideal. And this is called an interval estimate. So the 200, that original 200, was the point estimate. This is an interval estimate. So what we're going to learn in chapter 21 is how to do an interval estimate. And you will see that there are various tables for different levels of size n. Okay? Alright, so here's a couple of how-tos. Let me change the page. So let's talk about proportions instead. So I'm going to have something called p hat, which is a sample proportion. In statistics, when things have stuff over their heads, like bars and like this hats, that has some kind of a sample value. That's a clue. Alright, and we spend a lot of times looking for clues. So I'm going to say that my p hat for some kind of a problem is 0.5. And here again, if it turns out to be 0.5, I'm great. If it turns out to be something like 0.48 or 0.53, then I look bad. But what I want to do is set up an interval so that I'm going to have a good value. Alright, so we have different levels of confidence. Oops, ran out of space. And that's okay. So one of the underlying assumptions here is that we have a normal distribution and that our n, our sample size, is greater than 30. And I'll make sure it always is. Okay? So right now, let's look at proportions again. And let's say I wanted to find a 95% confidence interval for some proportion p. Now, when you pose the initial question, I should say, you don't call it p hat, you call it p. P is the population parameter. Remember that? We talked about populations have parameters, samples have statistics. So this is really the population proportion. So you pose the question on the proportion, but you use the sample to give you the answer. Okay? It's kind of confusing, but after a while you'll get used to it. Alright, what is the beautiful formula? So it's p hat plus or minus z, and we'll talk about that in a second, times the square root of p hat times 1 minus p hat all over n. So I know that looks really scary. Hang on a minute, let me clean up that n. This really sucks, using fingers rather than stylus. Okay, that's a square root. Ah, beautiful. Let's do a sample. There. Okay. So, what if I have 500 packages and I'm sending them through express mail? And I believe I have 95% confidence. I have a 95% confidence level that packages will get there on time. Alright? And I take a sample from those 500 packages, and I find that 400, oops, sorry, my iPad is getting wonky, that 480 packages arrive on time. So, how do I construct my p hat? So p hat is the number of successes, and successes is going to be context driven. All of these are going to run off stories. Over total number of total number of trials, if you think of it like that. So in this case, I had 480 packages that arrived on time out of a total of 480 packages, and the dog is sitting on my calculator. I'll have to wrest it out from, oh no she isn't, it's right here. Good thing. Otherwise you would hear a lot of unhappy howling. Alright, just hang on. Maybe I can do it in my head. I doubt it. Don't go anywhere. Okay, so that's equal to 0.96. Alright, did everybody get that? Good. So, let's... And under the square root, we have p hat times 1 minus p hat, so all over n. So let's just take a quick look at that. So that's going to be 0.96 times 1 minus 0.96 all over my n of 500. Yes? Good. So that's going to be 0.96 times 0.04 over 500. So what are we going to have? Let's see, 0.96 times 0.04 is equal to 0.0384 in the roof over 500 in the basement. And let's see. Whoa. And that's going to give me 0.0000768. But remember, I'm going to take the square root of that. So I'm going to have under the square root 0.0000768. And when I do that, I get 0.00876. Now, if you look in your book, and I forget what page it is, and the dog is actually sleeping on the book, you will see that z represents a horizontal value from the normal curve. And when you have 95% confidence, the z is 1.96. So I can put all this together, and I'm going to have 0.96 plus or minus 1.96, there's your z, times the 0.0087, whatever I said, 876. Okay? Then we're going to start putting things together. I'll multiply that last term by 1.96. And that's going to give me 0.017. And now I'm going to round up, and I'm going to have 0.02. Okay? So I'll have 0.96 minus 0.02 is equal to 0.94, and 0.96 plus 0.02 is equal to 0.98. So we are 95% sure that the population proportion runs between 0.95, excuse me, my fault, 0.94 and 0.98. Pretty cool, huh? Good job.